everyone. How's it going so far this morning? Good keynotes? I missed them all. So hopefully there will be videos of it. Anyway, like I said, I'm doing practical functional programming for the modern web developer. And I hope you all came here with the big question of what ZZ Top, Cthulhu, Attent, and making pea soup have to do with programming, because we're going to answer that very important question. But first of all, who am I? I am an iOS developer at the Church of Jesus Christ of Latter-day Saints. And the thing that keeps me going every single morning when I go to work is reviews like this one we got for one of our apps. I didn't truncate any of that. That's the entire review. So I tried to shower this morning. Say what? Yeah, it's a good point. Anyway. But seriously, okay, in a previous stage, I was a web developer. And in fact, at work, I do a lot of web development because the app has a lot of web-based components. I'm saying all this to give my credentials to talk to you about web development, right? Who wants to hear from an iOS developer? I run a screencast series called Learn All the Nodes, where it's about Node.js, and I guess now also io.js. Yeah, I've been doing web development for like 8.5, 9 years now. So anyway, I want to tell you about my road to functional programming. And the reason I want to do that is because functional programming is kind of different than probably a lot of the programming that you're already doing. And sometimes we can meet new things with resistance. So I just want to tell you how I arrived to where I am today. My journey started back when I was a kid. I was doing GW basic stuff for fun. My dad taught me. That was my favorite program. It annoyed the parents. And when you're a kid, you know, that's good stuff. I learned how to use Control-C as a result of that program. Anyway, it continues on. 1997, in Cadott, Wisconsin, there's this big concert called Rockfest, and a whole lot of bands come to it. And they're traditionally sort of like heritage bands, like ZZ Top or legacy bands, whatever. The people who aren't really making new songs anymore, but were huge back in the day. So at Rockfest, I, of course, did not go see ZZ Top. I sat in a tent and read a book called C++ Primer for Non-C Programmers. So at this 3-day rock concert with all these legends, I saw 2 bands there. It was Air Supply in Boston, and I was like, hey, I got my money's worth there. Yeah, I'm not ashamed to admit it. I really enjoy Air Supply. They're fun. Anyway, I learned about pointers. It finally clicked. Got to school and did Java there. Then there's like this weird swirling vortex that we're going to skip over for right now. This was part of school. We'll come back to that. Got out of school, did some C# at a job, moved to Texas, and I worked for National Instruments doing LabVIEW code. This is not like a flowchart describing the code. This is the actual code. When you write LabVIEW stuff, this is what you do. You draw these things together and wire them together. So very, very different. But it has some really cool properties that we'll get to in just a minute. And then I got into web development, and I think this spider's kind of smiling, and I really enjoyed getting into web development, so I stayed there. And in that time, you know, I've kind of done the usual suspects. I put Python on here, but it's kind of like I've run a few tutorials or something, but hey, got the badge for it, so. Anyway, all right, so let's go to that Swirling Vortex. It was a class in school. It was Principles of Programming Languages. And all the work in that class was done in Scheme, which has since been renamed to Racket, which I think is a hilarious renaming because, you know, keeping the whole mob thing going there or whatever. But it was really, really weird. It was like being hit in the face with a 2x4 trying to figure this out. Part of my frustration that semester might have been I was biking to my job. I was doing early morning custodial. It's like 4:30 in the morning. I'm going down this dirt hill in the middle of the night with my backpack, my laptop case, trying to carry a guitar. Not very smart. I fell down, went to work, got to the library later that day, opened up my laptop, and it had cracked pretty bad. And like I literally had about that much workable space down in the lower left of the laptop screen. So I'm writing all these programs in this new language. It's really weird. And I don't know. I had a really bad attitude during that class, and it's really a shame because it was awesome. But here was one of the first things that blew my mind. When I pick up a new language, like I try to do something simple, like declare a variable, print it to the console, right? How hard is that? Couldn't figure out how to declare a variable. And like most human beings, when I encounter something I'm not familiar with and that's different, my reaction was to say, That's just stupid. Like, who would ever use this? What a dumb thing. And that's how I thought about it. So I missed a really good opportunity to learn some cool stuff, because we did some cool things like building abstract syntax trees. So we wrote a Scheme program that would like convert Scheme into Java. Like, it would just do it, and that was pretty cool. I mean, I'm not a big Java fan, but the fact that we could write a thing that could just translate a language like that, that's pretty neat stuff. Anyway, the big development came when I learned this. This was my red pill moment. Whoa, wait a second. What if you actually could do real work without declaring variables? Maybe I'm the one who doesn't know something here. So anyway, let's talk about what that other thing is, the red pill. But to understand it, I want to talk more about who here, first of all, like thinks you know functional programming well. Awesome, that's what I was hoping for. Okay, so like the first half of this won't be wasted for most of you. I apologize if you're already pretty familiar with it. Let's talk about what it isn't first, because that's something we can sort of reference. Most of us know imperative programming, which is basically you write a program that executes a statement that modifies the state of the machine, mutates the state, you might say, has side effects. An example program of that is this amazing little thing. So we can put on our computer hat here and imagine what the computer is actually doing. So on the first line, we make a little box called X. We put a 3 in it. Then on the next line, we grab that 3, add 5 to it, stick it back in the box. And then this, like, who knows exactly what it's doing, because it depends on where you're running it. If you're in a browser, it goes to your DevTools console. If you're in Node or something, maybe it goes to your command line unless you changed it. But that's the basic flow, is like you're just executing statements that change things about the computer's memory, for example. Okay, that's the basic flow, and it seems really nice. It's kind of logical, but at the same time, for me to write a program this way, I've got to start thinking like a computer. The trouble is, I'm not a computer, and I don't think any of you are either. Robotics haven't gotten quite that far yet. But so why do we make people do computer things, right? We should be humans, and humans play Domjot. Is anyone getting that reference? 1, 2, okay. Star Trek: The Next Generation. It's a great episode anyway. Captain Picard got stabbed in that one, so take that for what it's worth. Yeah. Oh, sorry. I mean, moving right along. Yeah. So I would say this causes some problems. One of the big ones that's really a thing nowadays is concurrency. Like processors, we really can't cram more transistors onto them, so everything's going multi-core. Well, if I'm modifying the computer state, and let's say I'm on thread A, and I've got a reference to some object, and then there's some other thread B with a reference to the same object, one of us could pull the carpet out from under the other and change some value we expected to be a certain way, right? That makes sense? So to combat that, we've come up with all kinds of crazy things, mutexes and semaphores and locks and all that. Who here has ever done multi-threaded race condition debugging? How many of you enjoyed it? Okay, I mean, it's a good challenge. I'm not going to say it's not a good challenge. Kind of the same way that like climbing Mount Everest is. I mean, you can brag about that. But personally, I'd rather not do that sort of thing. And the reason we have to do that is because of mutable state and conflicts with that. I also think it makes it more difficult to read a piece of code and understand it. This is the JavaScript array pop method there. If I write that and actually call it, I'm just getting the prototype method there, but if I actually called that on an array and I put it 2 times in a row, like I would just look at that and I would see the same thing in my code, but what happens is actually different each time I run it. And that's not particularly visible from the call, right? I mean, it looks the same, but the results could be completely different. And so it makes it really hard to understand, maybe not in the array pop because it's kind of a simple one, but think of if the method was like debiting from a bank account or sending emails to people, or the nuclear launch codes were contained in that method. Like you're just not exactly sure what's going to happen with it. And so that's kind of confusing. I would also say that testing is quite a bit harder because in testing, you're not just testing stuff, right? To test something, you have to create this world of state around it and then run it. So then you have to start worrying about the order that the tests run in, unless you're doing a good job cleaning up between all of them. And you also have to make sure to clean up after it. So it's just not quite as straightforward, I would think, as the alternative that we're going to get into. Microsoft did a pretty good write-up of what it means to do imperative programming. You just basically, you write the code in exacting detail. Like you really have to become a computer and give instructions to a really high-speed idiot, which is what a computer is. So Eloquent JavaScript had this really cool thing. If you're going to do pea soup in imperative programming, I mean, you'd have to say all of that. In excruciating detail, you'd have to describe what it means to soak the beans overnight. You couldn't just assume that the computer knows what soaking the beans overnight means. Or like, you know, if you're a person talking to someone else. And that's a big blurb, and that's kind of awful to read. I don't know if anyone actually wants to finish that, but I'm happy to move on unless I see a hand shoot up in the next second. Okay. So examples of imperative languages, they're up there. Yep, examples of imperative languages. So I just want to say a word about object-oriented programming. Basically, you know, the gist of it is group data and the functions that change the data together. That's an imperative thing. And like one of the big things, it's supposed to remove all the big global state of everything. But it doesn't really do that because zoom in on a class, right? And it looks a whole lot like a program in itself. Anywhere in the class, you can reference stuff in the class and change it. You can do all the pulling the rug out from underneath you that you could do in any other setup. So I'm not really a huge fan of OOP. It's one of the necessary evils we live with in the current state of the world. Hey, maybe we could mutate that state with more functional. Just made that up right now. That's pretty good, huh? All right, so what is functional programming? Enough of this, whatever you've been going on about. It's kind of more of a continuum than like an either-or type thing. In functional programming, you're going to use things like this. You'll evaluate expressions rather than statements, and I'll get into examples of what that means. State is immutable. It means you can't change it. Once you've defined it, it is what it is. You can make other things, but you can't, for example, like have some object, have two people pointing to it, and if this person changes it, like he can't change it. So it would have to be a completely different instance of the thing. There's first-class functions, closures, higher-order functions, lazy evaluation, composability. So let's talk about what these are. Evaluating expressions, going back to the array pop thing, I declare a variable 1, 2, 3. I pop something from it. The whole point of this is to change A. Like it returns a 3 to me, and A is different now. So I've mutated A, I've changed it. Whereas in the functional thing, imagine there's this kind of black box function called pop. Into it, I send an array, and it evaluates what it means to have popped something from this array. So it returns to me in a tuple a 3, which is the same return value, and then an updated array. But these are not, which you can't see, those are not the same object. That's a brand new one over there. So if someone else were pointing to this, I didn't just change their array. I just evaluated what it means to pop something off an array. Does that make sense? Am I explaining that well? Okay. So that's a huge part of it. I'm going to skip the immutable state one because that's pretty self-explanatory. First-class functions, JavaScript has this. So have you all used JavaScript? I kind of figured that was the only language everyone would likely have in common here. Anyway, functions are pieces of data like anything else. You can set them to variables. You can pass them to functions. And that's pretty cool stuff. Closures. Do you guys know what closures are? OK, so we can go through this quickly. Basically, here's the example. So we got this outer function greeter that returns this inner function. But when you call it right here, you pass in world, and then that function greet gets returned. And you could call that a day later. And when you do it, I wish I had a laser pointer, but oh, I guess I have the purple line there. In the inner function, it remembers what name was. So it kind of stores it. And honestly, working with JavaScript like this, I found that closures and first-class functions like that completely do away with the need for classes of any sort. And also, like, if you've ever implemented the command pattern in another language, you had to do that because the language you were working in didn't support this. I'm a big believer that the Gang of Four book, the design patterns book, every one of those exists because the language it was written for was deficient. Like it didn't have all the features it needed. So anyway.
Well, what did you say, command pattern, what?
If you've done the command pattern in say, C++ or Java, you wouldn't, do you know the command pattern? Oh, sorry. Gosh, how do I explain it? So in the command pattern, you would have a class, and you would give to the class probably in its constructor data that it would need to be invoked later. So like a user interface button might have that. You might attach to a button some command. But that's just a really difficult way, I would say, of doing the same thing that Clojure with a first class function would get you. Does that make sense?
Enough.
Okay, we can talk more afterwards if it's not too clear. So then higher order functions. For a function to be higher order, it has to do one of two things. It either has to take a function as a parameter, and arrays for each is an example of that. You give it a function, and then it goes through the array and calls your function, passing in each element from your array. Okay, so the other thing is that it could do to be a higher order function is to return a function. And if we go back to this example, greeter is higher order because it's returning a function. So that's another feature that you would find in functional programming that is not as common in imperative. Lazy evaluation is something that you would find in functional programming. With lazy evaluation, we don't actually care when things happen, just as long as like something happens before something that depends on it. And also, things don't get evaluated unless they're actually needed. We're going to see a really cool example of that in just a little bit here. But let's go back to LabVIEW. One thing that was really cool about LabVIEW that I didn't appreciate at the time is you didn't actually know exactly when each VI, they're called, was going to execute. You knew they would, but you didn't know exactly in what order. But you knew that like for this one to execute, this had to go first, which meant that that had to go, so that one would have just started. But it just made sure all the dependencies happened before the later things. Now, what was cool about this, speaking of concurrent programming, when I started at National Instruments was right about the time when multi-core processors were becoming a big deal. And as you know, like if you write an application, it doesn't automatically take advantage of having multiple cores on a machine. If you have a web app and put it in a server that can spawn different threads, you get it. But if you just wrote like some Ruby app and didn't explicitly take advantage of the multiple cores, you're wasting a lot of computing power, right? Well, LabVIEW just sort of worked on multi-core. They just updated the VM running it, and everyone's software that had been written in LabVIEW just magically got to take advantage of the multiple cores because these would just be spun up on different processors or whatever. And like it's a huge speed bump for a whole lot of people just with no effort really on anyone's part. So that was a neat feature that I missed because I was grumpy when I worked there. And that might have been because monitors were a whole lot smaller back then than they are today. And you can imagine, you know, flowcharts, why they're no good, because you can't see them. Same thing here. It gives a whole new meaning to spaghetti code if you do it poorly too. Anyway, so here's an example of lazy evaluation. I think this line of Haskell here is just brilliant. I didn't write it, but it's still brilliant. I mean, it's all the more brilliant. It's trying to say is I'm not really that smart, and that's a good line of code. Total failure there. Anyway, all right, so we are actually going to get into what's going on there, but this one line of code, it's a function definition called fibs, defines the infinite Fibonacci sequence. And it does it fast, actually. It's not like the naive recursion one where you solve it twice and for every step down the chain. We'll get into how it works, but so what the lazy evaluation gets you is that line generates an infinite sequence, and what normally happens when you put an infinite something in a program. Yeah, you learn how to use Control-C if you're fast, otherwise you see the explosion in your console. Well, that doesn't happen here in Haskell because, sure, great, you defined it, but you're not asking for it, so I'm not going to give you any values. So it doesn't waste time doing that, which is kind of cool. So those are sort of, oh wait, one more, composability. So in object-oriented programming, for example, like you come up with this constellation of classes that have data and the methods that operate on the data together. But it's like, I find it difficult to put those together and to have them play with one another. It's like you create a special one for each little task that you want to do. The mode of thinking in functional programming is that you have all these little small functions that you string together and you get really cool results. Like in this one, the colon there, that's a function call. Obviously that one is too. Zipwidth is a function. The plus sign in parentheses means just treat that as the function, don't actually perform anything. That references itself, which is a function. Tail's a function, and then of course that represents itself. And again, we're going to show how those all work together. But you have these little tiny things that are really simple to understand. You put them all together and you get really cool, I don't know if emergent behaviors is the right thing to say from it, but it's really, really nifty. So a functional language then again, like it's not an either or thing. It's not like Haskell's functional and Ruby isn't. It's a spectrum, and a language is functional to the extent that it facilitates those things we just walked through. And what's funny is like when I got into functional programming for serious, I was a Rails developer for a long time. Like I discovered everything that I loved about Ruby was one of those things that came from the functional world, like the map and inject and all that stuff. Like that's all from here. And then like as examples, Haskell does all those things a lot. Java obviously less so, although they do have lambdas now. If you're a Java programmer, like consider yourself lucky there because lambdas are good stuff. Is anyone here a Java programmer? Okay, good, yeah. So you got lambdas, so that's cool. All right, so before we get into the tips, we actually are going to get into them. Let's bust some myths about functional programming. People say it's slow because you're creating all these objects. It's not true. Perhaps in like something like JavaScript, if you did a lot of functional stuff, it might be slow because the garbage collector isn't designed to handle that. But in Haskell, for example, the compiler for it, like it compiles the programs down to executables. It's not interpreted. It's really fast, and it rivals C performance in a lot of cases. Another thing that's said is that it's hard. It's like saying cursive writing is hard if you learned printing first, right? I mean, it's weird. You're used to these nice letters that look somewhat like this, and then you have to do all those weird loops and joining them together. But there are countries in the world where they learn cursive first, and it's just not a big deal. It's easier for them. And so the other reason I don't think it's hard is, who here knows what the most well-known programming language in the entire world is? Not JavaScript. That's what I thought too when I was asked this question. The result, the answer will blow your mind. See, yes, Excel. This. There are a whole lot of non-programmers who know how to do some pretty complicated work with Excel. And Excel has all the makings of a functional language. I don't mean like the VB extensions or whatever. I'm talking about just like put a value here, define some function here, change the value, it updates. I mean, that's really easy to grasp. And a lot of people without the same training that we have and the practice we have get this. So I don't think functional programming is hard at all. It's just different. We all happen to learn, well, I don't know if all of us did, but a lot of us probably learned imperative first, and you just have to think differently. So it's weird, but not hard. All right, so yay, the practical tips for all you modern web developers. Let's get into these. First one is to learn Haskell. Now, I know in the description I said that, like, you know, you don't have the time to rewrite your whole code base into Haskell, and that's true, you don't, unless, like, you get really lucky at where you work. But that doesn't mean you can't learn Haskell. It will help you. It will change the way you approach programming. And here are a couple of good resources. I went through this edX course on it. It was taught by Eric Meyer. Has anyone heard of that guy? Yeah, he's a really smart guy. He wears awesome shirts. Like, that was one of the perks of the course, was he wears a lot of very colorful tie-dye shirts, and sometimes it like messed up with, I think it was green screened when he was shooting the videos, and so it caused some interesting stuff. But he's really smart. It's worth following him on Twitter. Another good resource is Learn You a Haskell, which is the URL for the book Learn You a Haskell for Great Good, which is a funny book title. It's got an elephant on it. That's kind of neat. All right, tip number 2. Here are all the data structures you need to program. And I'm only partially joking. A list, you might call it an array, and then the object, hash, whatever you want to call it. With those two things, you can pretty much solve any programming problem in a functional style. Joe Armstrong, have you guys heard of Erlang? He wrote Erlang, the language. He obviously is not a fan of object-oriented programming either. But this is a statement he had there, just that it's better to have a small number of ubiquitous data types than with a large number of functions that operate on them than it is to have a large number of data types with very few functions. So he's saying, like, these very basic data types, because his whole point in this essay, which I do link to at the end, there's a bunch of links there for all the stuff I researched for this. Where's it going? Right, he was saying that like data is dumb. Data is just stuff. It's there. It doesn't do things. So you don't need very much that's complicated to represent it. And so it's just, and I agree with this. It's just been a lot easier as I've shifted like my node development over to not relying on classes, or not that JavaScript has them. There's a fun little argument to get into, although ES6 changes all that, I suppose. But just the standard array type and the standard object type get the job done. Tip 3 is learning the FP vocabulary. And what I mean by that is, here's the pea soup example again, but it's much shorter because you get to assume that all these little steps, people know what they actually mean. You don't have to describe them in excruciating detail. And the only way you can do that is if you know what those words mean. And so I'd say FP has a vocabulary. There's a set of common functions that you would need to know to make use of a functional language. If you want to learn them, Lodash implements a boatload of them. So I really like that library. It's a good one. So let's go through what some of them are, because this is important. First is, was there a question? OK. First is map. You've probably used this, like Ruby has it. All kinds of languages have it. These little things at the top there, that's how you would define a type in Haskell. This is just saying I'm naming something called map. It takes a function that takes something A and returns a B. And then it also takes a list of A's, and then it returns a list of B's. So to call it, you would, in Haskell, you'd call map the function and then the thing you want it to act on. And this is an example of a node project I have. I don't like to pass database objects around in the whole system. So when I retrieved a bunch of things from the database, I have a transformation that turns them into just those basic objects from the two data structures that matter. And so to do that, I just map it, right? So get the array of things, apply this function to it, hand me back an array that is the result of mapping those, which is way cooler than like writing a for loop and doing the same thing. So that's map. It's pretty simple. If you have any questions or get confused or want me to go faster or something, say something. Sum, like how would you sum up an array? Would you write a for loop, declare a variable before it, count through it? That would kind of stink. Ruby gives you can just call sum on an array, which is a functional concept, which is kind of nice. And here's the suboptimal way of doing that in JavaScript, I would say. Much better to just call sum. I don't think JavaScript has a sum on it, but it'd be pretty easy to write one in terms of some other function, which we'll see in just a second. Here's a fold. This is a huge one called inject in Ruby. Or I'm sorry, yeah, reject in Ruby. It's called reduce in other languages. JavaScript has it in the later versions. It's a great one. Basically, it lets you take something and reduce it down to a single value. Now, that doesn't mean it has to be a number. That single value could be an object or something else. But here I'm defining sum in terms of a fold. So I'm just calling the fold function. I'm giving it some function to apply. So this is saying pass it a function that takes an A and a B and then returns an A. So plus matches that. Then I give it a starting value. This is usually called the accumulator or something. And then a list of things to reduce. And then it does it. So here I'm defining sum as in terms of fold. And then I call sum on the list and I get 6. That dash dash, that's how you do comments in Haskell. That's not like actual code there. Does that make sense? Any? So the plus operator is considered a function? It is, yep. Mm-hmm. I missed that in the first
and it's just in parentheses to indicate treat this as a function right now.
Right. Otherwise, it would try to apply the plus to fold and the 0, which would make no sense. And that's exactly what the parentheses do. Yep. Any other questions? OK, let's get to another one. Oh, here is an example in JavaScript, something that's actually useful. This is flattening an array in terms of a reduce. So you've got this array of arrays, and I reduce it by calling this function on it. So at each iteration, I get some accumulator value, which will be just the first value in here, the way I called it. And then it will be called twice, passing this in and this. And so what it does is just take the accumulator and concat B onto it. And so the result is a flattened array. This particular one wouldn't work if you had another layer of depth in there, but it's really easy to adapt it to do that. I did that, but the code didn't really fit on the slide, so just trust me on that one, I guess is what I'm saying. It really does work. Does JavaScript have an array flatten? I don't think it does. Ruby's got it, because Ruby's got everything. It's a good language, but JavaScript doesn't. And so there, you can have that, and now you can flatten a 2D array. Honest to goodness, I can't think of any problem that could not be successfully modeled as a reduce. Doesn't mean it's the best way to do it, but everything pretty much could be modeled as a reduce. I haven't come across something yet that I couldn't. In a web app, the entire request response cycle, you could think of it as a fold or a reduce or whatever. A request comes in, you apply some function to it, and it spits out a reduced response. And that's the whole thing right there. Next one, filter. You might have seen this one. It's called select, I think, in Ruby. What? Oh, yeah. Is anyone getting this one? The joke here? Oh, man. It's the Star Trek movies. All the even ones were good and the odd ones were bad. Anyway, so given an array, the filter function just returns you a different array containing all the members that returned true from the function you gave. So my function is good, returns true if the number is evenly divisible by 2. Yeah, so that's why you get 2, 4, 6. It's pretty simple. That again beats a for loop with an array where you're manually accumulating these things. It reads a lot clearer. And it's even clearer to me, like, if you don't pass the function in directly like that, if you define that elsewhere, then you can just turn that into a nice one-liner. Takes the first X items from a list. So with that Fibonacci sequence we saw earlier, now it will actually start calculating them. And I'm just grabbing the first 5 of them. That's a pretty simple one. Head and tail, pretty self-explanatory. Head grabs the first thing out of a list. Tail grabs everything after the first, which of course leads to head list. Oh wait, cons. This is called cons, and it takes a lone item and a list and puts them together. And so then putting all those two things together, if you take the head of a list and cons it to the tail of the list, you just get the original list. That's a really common one. I think Lisp uses that a lot. Does that make sense? Okay, cool. Zip is a really neat function. Given a parallel set of arrays, it pairs the corresponding elements out of them. So 1 and 4 go together, 2 and 5 go together, 3 and 6 go together. Seems like a weird thing. When would you ever use that? Wait for it. Zip with does the same thing, but instead of just grouping them together, it applies the function to the corresponding elements. So let's break down how this thing's working, shall we? We have to give it a few first base cases to get it going, and that's what's happening here. But then we're saying zip with plus, because we want to add the things together, because that's how the Fibonacci sequence works. Our self with our tail. So essentially what that does is it takes like 2 copies of the Fibonacci sequence and shifts them, and then starts adding the corresponding things together. Did that make sense? Yeah. Yeah, whoever did that was a genius. Like, seriously.
So I need a little bit of a refresher on my Haskell because it's a little weak.
Okay.
So I see a lot of arrows up there and a lot of brackets of sorts.
Yeah.
So what we're saying is zip with double colon means assign, right? Is that what we're saying?
The type of. The type of zip with is.
Type of zip with is. Okay, can you read that out?
Yeah, did you want to take it?
Sure.
Okay.
Sorry, I don't mean to.
No, please do.
So the type of zip with is a function.
So
from
function
A
is
to there's a function.
Is.
Yeah, the first parameter is a function from A to B that returns a C. Second parameter is a list of A. Third parameter is a list of B, and it returns a list of C.
Okay, so.
And A, B, and C are just some type, and just if the A's match and the B's match and C's match, obviously.
And they're not necessarily different. Like A and B could be the same type,
right.
but it also allows for them to be different.
So I'm a little confused because I don't see something that indicates like it's a return value. I just see the same arrow repeating over and over.
The last one is always the return value.
So last one means return.
Mm-hmm.
All right, so it's a type of, and how do we know that A is a function?
A is not a function. What is the function is the part in the parentheses. Those are in a parenthesis, or they're in between parentheses to indicate that those three together are to be treated as a single unit. That's a single function, which in this example happens to be the plus.
Okay, so it's saying it takes a function which takes two operands and returns a third.
That's exactly right, and that's what this is.
Okay, and then we're telling it that with the first operand, which is the function, or no, the function is...
This one? Or...
I'm having trouble parsing this.
Okay. No, it's weird at first. It really is weird. It takes a little bit of time.
No. It seems like that definition reflects that it's curried by default, right?
That's right. Haskell curries everything by default.
In fact, underneath Haskell, actually functions only have one operand. So since it does curry by default, you end up having multiple, but really you think of it as just one.
Briefly, what currying is, it lets you treat a function with multiple parameters as, like, you could just call the first one and it would return a function that would take the second, kind of a thing. I didn't dive into it too much into this talk, but so the plus is that thing because it takes two things, returns a third thing. The list of those is ourself, the fibs itself, and then the second list is the tail of fibs, which would remove the first element from here and then return everything else. So that's where the kind of like you have two instances of fibs, even though in the memory it's not two instances, but just think of it as like taking the two, shifting them, and then adding the corresponding things together, if that makes sense.
I'm going to have to do that Haskell and use some good or whatever.
Learn you a Haskell for great good? Yeah. It's weird at first. Like, it was really hard to grok that. And like still sometimes I'm like, wait a second, does that associate left or right? And I have to look it up because it's different. But, oh no, okay. So let's see. Zip width. I was showing a cool example of zip width. Yeah.
Bother with the operands. Goodness. They're all the same.
Yeah. Sometimes, like, when you're defining a function like that, you'll specify to, like, in between the double colon and the rest of it, like, you might constrain the type of one of those further. But in this one, it's pretty open. It can do whatever. And again, that doesn't have to be a plus. That could be any function that fits that type up there. So I hope that slide was more helpful than confusing. But I'll post these, and so then you can look at them. And
I get it conceptually.
Okay.
From, like, I understand what you're saying, I think. So zip width here is taking three operands, right?
Yep, that's exactly right.
Yeah, so I get that. It's just I'm having trouble mapping those three operands to A, B, and C. And does that A represent the same as that A, and that B represent the same as that B kind of thing?
They're types, yes.
Okay.
They're types, yes. And truth be told, like, I can look at this and I can accept that it works. But when I try to imagine in my head how it actually pulls that off, like, I'm just like, I can't do that. So I know it works. I'll let it be.
Okay, I guess I'll do that too.
Anyway, okay, so next tip. Never code control flow yourself. Use a function to handle that for you. By control flow, I mean, like, don't ever do a for loop because there are functions that handle that. And writing a for loop will just confuse your code and make it harder to read. It doesn't. And I'm actually going to say bad things about for each in just a little bit. I'll show a better way, even better than that. It'll make sense. So yeah, here it is. I guess I do it on the very next slide. Tip 5, never use for each, which I just said using number 4, because anytime you have an each, you're saying, hey, I'm going to start mutating state. And mutating state's bad, right? There's no reason to call for each unless you're about to go mutate some state. It doesn't return anything. It just goes through them all. So if you need to evaluate something, there's a better way to do that. Like, if you need to collect a collection of running a function on something, don't use for each with a loop or an array outside of it that you feed stuff into. Use map. Search the rich ecosystem of functional functions to find something that you want. Now, there will be times when for each is okay, and we'll talk about that too in just a second. How are we doing on time? We've got... okay. 6, isolate your code from state. It's really easy to do because Haskell has no side effects. And I'll just let that sit there for a moment. But in seriousness, it's really easy to do that in Haskell because really Haskell doesn't have side effects. That gets into some details how it actually does things that are beyond our scope here. But the real world obviously have states. If you do web apps, you probably actually do need to modify a database. If you're in the browser, you have the poster child of mutable state, the DOM, which is... That's why I like Node.js. I've met a lot of people who hate JavaScript. And what I've determined is that people who hate JavaScript hate the DOM API, not JavaScript itself. I mean, JavaScript has some warts, but the DOM is the DOM, and we all live with it. Anyway, a guy named Gary Bernhardt, I'm not sure how he says his last name. We'll just say Gary. He did a really good talk called Boundaries, where he references a screencast he made called Functional Core Imperative Shell. And the idea of that was limit your app's exposure to the outside world. And this one I've had really great results with. Think of your app as this cute, defenseless little puppy that does things really well because I'm a dog person, and if you give a talk and you like cats, you can put a cat in there to represent something that does something well. Anyway, so you have your app, the thing that actually does all your business rules on the inside. Then there's this horrible world of HTTP requests that comes in. There's a database, which is a cylinder because that's what databases are. You've got GitHub webhooks, which I guess are just HTTP requests. You don't want your app internals to know anything about those, right? So you give this nice thin imperative shell around it that can translate things like this into meaningful inputs to your puppy. So maybe like puppy chow or something. What's one thing that's really cool that comes out of that is your app then doesn't really care if it's part of a web app. It doesn't care if it's a command line utility. It could be mounted into anything. There's a lady on Twitter, her name is Jessica Kerr, and she did a really profound tweet. She said, here's how to write a command line application. Write a library that does all the work, the puppy, and then write a thin shell around it that calls into the library. And like that model works great. So it's just some examples of that. Like here's a standard Rails CRUD action. Maybe the style has changed, but this was how you did it in like the 7 lines or so. Where the request comes in, you get the params out, you make a new object, you save it, set a flash notice, you redirect, all this stuff. I guess there's the respond with now, but that's showing my age here, I guess, or how long it's been. So hang on to that for just a second. In Node.js, how many of you have worked with Node before? Okay, about half. So a request handler in Node is just a plain old function that takes a request and a response. A middleware, this is now an Express, not necessarily Node, can have the third one. I mean, it's the same thing as a handler, but just by convention, people drop the next. So like to declare a route, you just say, here's the route. When it hits the slash and it's a post, invoke some function. So here's a bad translation of that old Rails style into Node. It's kind of a rough port. And I just think that's really confusing and ugly. There's so many things going on here. We're dealing with making sense of the requests coming in. We're talking to the database. We're handling errors all in this one place. And that's really confusing. I don't like that. So here's a better way, I think. It's more better. That's how much better it is. This is a series of functions here that followed that recres next pattern that the others did. And this one here will take the request and give me some sort of a user object based on the attributes that I got, and stash that somewhere. And that's all it does. Really easy to test. I can fire that up, a test for that, without having to actually send a request to my app. Maybe I should validate that it was good credentials coming in. Why on earth would that be part of a database object, incidentally? I'm not a huge fan of Active Record anymore, but Active Record would put that as part of the database. Why? That has nothing to do with databases. You're just validating user input. You probably ought to persist it, so that's often its own thing, not polluting any of this. You need to give it a response. By the time you get there, everything's already done. If there was an error, you have some other function that sits to the side and handles it. When I then look at this route definition, that looks really simple to me. Like I can just read that straight down what's going on. And that's awesome. And each one of those pieces is independently testable, which is really cool. So then the corollary I get from this is also try to isolate your app from its dependencies. And so the way I phrase that is rather than writing a Rails app, write an app that uses Rails, if that makes sense. So Uncle Bob Martin, he wrote a really good article about that that will be at the end of the slides. Separate your app from the database. Your app shouldn't care if there's a database or not. Listen to me dictate this. Step 7, never use ORMs or ODMs. That one might be controversial, but I think they're one of two things. They're either a design smell or they're unnecessary. Design smell because, much like the tendrils of Cthulhu, little ORM objects sneak their way into all the different parts of your app. They try to make you think that you're not talking to a database. You are. It's not the same thing as just a plain old object. So then if you section all the ORM interaction off behind something the way that Uncle Bob would say it, why use an ORM at all then at that point? So same with ODMs.
Why use an abstraction layer that is specific to one specific library that's supposed to abstract it so that you can use it with multiple, like, the purpose of an ORM is self-defeating in what it does.
I agree. And then when they change it and your whole app breaks, you end up on Rails 2.3.8 for another 5 years, missing all the security updates. Like GitHub, I think, as of a recent time, was still on 2.3 something. I mean, they've got the resources. Say what?
If you patch activate yourself, monkey patch it.
Yeah. Oh, monkey. Yeah, it is. So I think ORMs are a design smell because they end up like Gargantua from Interstellar. Every CRUD app I've worked on has had a user model. Anything that's tangentially related to users somehow finds its way to attach to the user model. And then have fun changing that, have fun testing it. Anyway, yeah, it's a black hole for code. 8, you can get actual unit tests. Ruby on Rails lies about unit tests. What's a unit test? What do you do in one?
Test an algorithm.
Yeah. What's a Rails unit test?
Integration test.
Yeah. Your database is a third-party service, even if it's running on your development machine. So to do a unit test, you have to talk to a database? That's really weird. It's slow. And as a quick story, my last full-time job, we had a test suite. A bunch of us got hired at the same time, and one guy, he fired up the test suite before going to bed. 10 hours later, it hadn't finished. He didn't actually know how long it was going to take. That loses a lot of the value of unit tests in my mind. And a lot of that is because of database interaction. It takes a long time to talk to the database a lot. So just test functions. Pipe said the little stream, tip number 9. Streams are amazing. They are kind of to time what arrays are to space, if that makes sense. I've really got to go through this, I'm sorry. But Highland.js is a really good streams library. All those cool functional things we had on arrays and lists, you can have them on streams with something like Highland. So here's something really cool. I can stream a file off the disk, pipe it into a gzip stream, and then pipe that to some other place where I need to put it. And those 3 lines right there have read a file, converted it to a gzip thing, sent it off to some other web server. And it's really clear what that's doing. And then the next cool thing after that is functional reactive programming, which builds even more on this. I'll skip the Wikipedia thing because Wikipedia can do that. So this code example here, these are all the things it needs to do. We need to watch a text field, make sure that the value in it has a length greater than 2, send a request to API. It's an API search. If the user has stopped typing for 500 milliseconds, we send the request and then we deal with the results. Imagine in your head how you might start doing that imperatively and then cringe. But here it is in FRP. First, we just get our fields that we're watching. We have a thing that, given an event, can get the key that was pressed out of it. A filter function that will check the length. Notice that's a higher order one, so we could change the length. The actual thing that will go to Wikipedia, and notice that we grab a promise from it. Then we have an on success if it all worked. Here's where we use for each, because in this little sliver, we are intentionally modifying state, so a for each is appropriate there. If it fails, we have that. And then we have the thing that actually does all the work. And just like, look at how declarative that is. You can read that, and it reads a lot like the bullet point list I put up a moment ago. And it's really easy to understand that. You get exactly where everything is coming from. I'm sorry we can't dwell on that longer, but there's how to think about that, I guess. And I guess, yeah, so that's it. I mean, that's the sort of intro there. Got like all these things here to look at. I'll just leave it on that side. Functional programming is awesome. It's really different. It's hard to get into. If you do get into it, you're going to beat your head against the wall. You'll have moments like that where you look at the arrows and you're like, what on earth does that even mean? But with perseverance and a good edX course and a few good Google searches, you can really get the gist of it. And even if you don't get the opportunity to program in Haskell full time, which is actually happening more and more, Facebook is starting to use it for things like you can look at imperative JavaScript code differently and make it cleaner, easier to test and maintain and so forth. So I guess go forward and work much awesome.